So in this video, we are going to be talking about what is an X-ray. So to start with, we have to go back and start talking about electrons. We get X-rays from electrons. Electrons are part of atoms, of molecules. So we need to somehow get electrons off of an atom in order to create an X-ray. So we need to go back and talk a little bit about chemistry. You guys remember you had atoms, and every atom has a nucleus. And inside that nucleus there are protons. And around this outside orbit there are electrons. So a couple other things you guys are going to want to keep in mind is something called the atomic number, which is always equal to the number of electrons of an atom. You'll also want to remember that the number of electrons is always equal to the number of protons. Additionally, remember, negative charges are going to be drawn towards positive charges. So we're going to use this to our benefit in order to create X-rays. We are going to apply heat to this atom, which will cause these electrons to break out of their orbits and travel to those positive charges. We are then going to be putting something in their way, a barrier. So when these electrons come in, they're going to be flying, hit this barrier, and come off in a secondary direction. Once these electrons have changed paths, they're going to be called something called a photon. A photon is simply a bundle of energy. And we are going to be terming our bundle of energy X-rays. So in this slide, we're just going to add one more fact to the photons. So here we're talking about photons. They are a form of electromagnetic radiation. We talked about them being a bundle of energy. What we're going to add in new in here is that they travel in waves. So we are going to need to talk some about that wave theory. And these photons, we're going to term them X-rays. Now, we need to deal with these waves. So here I've drawn for you guys two waveforms. We discuss waves in two different terms, wavelength and frequency. So the first one I'm going to draw for you guys on here is going to be wavelength. So we have two waves right here. The wavelength is simply going to be the distance between two waves. The other thing we have to look at when we're talking about waves is something called frequency. And here we are simply measuring how many waves pass by one certain spot in time. So this is going to be how many waves pass this spot in 1 second. And we'll be using cycles per second to measure our frequencies. So here we have a demonstration of two different types of waves. On the top one, you see we have a wave that has a really high frequency. There are a lot of waves passing past this particular spot in time per second. And they also have a very short wavelength. Now on the bottom one, it's kind of the opposite. This has a pretty low frequency. Not many waves pass by here. And it also has a very long wavelength. So one of these is going to make a better radiograph. And this one here up on top is going to have more energy. Along with more energy is going to come more force. And along with more force is going to come more penetration power. And I bet these terms are starting to sound familiar. We'd be talking about something that kind of sounds like KVP. So these right here, these are our X-rays. One down here on the bottom now, longer wavelength, lower frequencies. These are going to be lower energy and therefore would have lower penetration. They're not going to have enough power and force to create X-rays. So we are going to be using these short wavelength, high frequency waves in order to create X-rays. And that is how we're going to get an electron to change directions and come off in a short wavelength, high frequency pattern as a bundle of energy, a photon, a form of electromagnetic radiation, and we are going to use that to create our X-ray images.